what microbes makes you excited, Michał?
I would say that still the soil is our black box. It's pretty matching to the soil because we are finding still new things by the soil. And I usually use on my lectures an example that the soil science is not a rocket science. It's far more complicated.
That's something that we have caused or also as well, like extinction of microbes?
It is a good question and it's very hard to answer because our understanding of the diversity of the microbes is very limited.
And what is the future that you see for this kind of crops?
I would say that for some of the crops, some of the tropical crops, the value crops like cocoa and coffee, it started to be very problematic. And it started to be problematic not only about the weather extremes.
Is there something, Michał, that our audience needs to know about, like scientific breakthroughs that you didn't mention around plant sciences that you would like to mention?
As per general scientific breakthroughs that could be mentioned. So I would say...
Oh, thanks for coming to the podcast. We already spoke before and we had a great conversation, and now I want to bring this conversation to the podcast. You're known on LinkedIn, Macy, to be a very expert in scientific, like bringing scientific information to, let's say, also scientific experts around plant health and also soil health. But how would you describe yourself?
I would say that I'm a scientist by heart. I'm not maybe much of the social media fan, so the whole story with that LinkedIn activities doesn't really started with the passion to try to networking on engaging in some discussion. It started with more like a passion for sharing some insights. Basically, I started as a plant scientist. So my university background is on molecular plant nutrition. But then I worked for a while for the business sector, for the supply of raw materials for feeding the plants, feeding the bacteria, feeding the livestock. And then I moved to a completely different sector that connects the whole story. So basically on human toxicology, so working on human biochemistry to try to merge how the activity we do with the soil and how we treat and manage the nutrition program on the crop affect the end quality, what we get on our plates.
I'm just wondering, it was always like this? You were the kid that liked the plants, or that come later?
I would say I was always passionate about the plants. My family is much of the biological science oriented, so since my early childhood, I was always wonder on some complexities of plant and soil biology, and now the next generation of my kids are much passionate about the same topics too. So it seems to be a kind of family heritage.
Yeah. So you took it all over. So is that also why you're doing the things that you're doing right now? It's just a passion, or is there also another belief?
I would say it was always a kind of a driver in my life about the biology. I come from the biological oriented family, so I was always passionate about the soil health, about plants, and now my kids are passionate on the same topics too. So I guess it's kind of family heritage.
And I'm wondering, now you see generations after generations over generations, is there a big change in science over the years, or is it always like basically the same information that keeps but slightly?
I would say that in terms of regenerative agriculture, we are like going back to the roots. So there is a lot of the advancement of science, but there are the practices that have been done centuries ago. So in that term, I think that we are going to a better understanding of already the farming principles that were already there. So of course there is advances in some tool for assessing crop health or evaluating soil microbiology, but still that bottleneck would be our understanding of holistic soil health. So I would say that's the goal of the science to try to merge different fields, different complexities, to try to understand and put it into practical insight, how to use it in the practice on the day-to-day farmer practices.
What are challenges that you faced when you were starting in your career as a scientist that now you take a lesson from it and you believe that help you grow?
Yes, yes, indeed. I would say when I was starting, I would say the science is all about like specializing these pretty narrow fields. What I find most useful is try to pick up the data or pick up the insights over the emerging field to see this kind of interdisciplinary view. So for me, what is most important in the science is that interdisciplinary cooperations to try to turn that real data, so the raw experimental data, into the insight, but try to merge different fields to make it practical, understandable from different ways. And then that's the rest that I also specialize with, communicate it to the professionals, but also communicate it to the public. That's the critical point, to get all the stakeholders on the same page regarding the understanding of that complexity.
That is interesting that you mentioned overall, because I think it's interesting because science in some way, or the academical path in some way, takes you to the specialization. No, like must be the expert on one topic, on senior topics related to something really specific. But then it's true that we need the specialization is really good to understand how things work in a really deep level, but that is useless when you're not generic about how you apply that knowledge and how you build like the whole system. And I think it's interesting because it doesn't matter if it's in science or it's in business. I think we tend to have like silo views on how things have solved, and we see like there is puzzle, and this puzzle they fit solution problem, so solution solved, problem solved, sorry. But then it's when you discover that the puzzle is not only putting the two pieces together, it's actually putting all the other pieces together. Right now you only have two pieces that probably are not the whole thing. So I think it's interesting and really something to put into value that we need more, and we try to do it also in the podcast, is we talk a lot about the systemic thinking. Like, don't think only about your point of views. How is this going to impact all the other parts? Because that is when you will truly will have an innovation or a discovery that is impactful, right?
Yeah, that's the, let's say, definition and diversification between the basic science, that we are generating that new puzzles, but the implementation of it to the practical use is more like solving this puzzle or trying to connect the dots to see the big picture. So I think that a lot of the scientific communication on different levels is needed, at the university level, commercial businesses level, to general society, to try to merge the gaps, of course, to ignite the passion in the new guys to the industry, to take them to specialize in that field. But I think that the bottleneck of the academia is that if we over specialize in a very narrow field, we are a top expert of so narrow thing that our vision is tunneled. So we just need to have this kind of forums, whatever they are, the conferences. But in the science, there are usually specialized conferences. But we need to have this kind of the forum for like structured discussion to try to find that merging grounds and try to explore some new ideas, to exchange the especially the soil. The soil is the kind of environment that brings physical and chemical sciences, brings biology, brings economy to climate sciences. So it is like a common ground for a lot of the sciences.
Yeah. Now you're talking about soil, Michał. I wanted to ask you, what does an ideal soil looks like?
It's very hard to talk about the ideal soil, because in principle we have the soil, as in mathematic terms, it's pretty simple. You've got 45% of minerals, 25% of water, 25% of air, and 5% of organic matter. As simple as that. But in reality, it's far more complex, because that 5% ideally of organic matter is the volume that feeds the microbes. And we have the whole diversity of the microbes in the soil. So we need to take into consideration a lot of the variables to understand how the soil works. So principle, simple, but the reality is, as for most of the life sciences, is pretty complex.
I understand as well that it happens with everything that is ideal. Something is ideal only depending on the context, no? Because I'm thinking like, is it the soil of the forest here in the Netherlands better than the soil of the desert in the Sahara? And I guess that the question is depends on what. For sure, with the soil of the desert of the Sahara, you will not grow the trees and you will not grow the vegetation that is needed. But doesn't mean then that the soil of the desert of the Sahara is a bad soil. I guess it's the ideal depending that take into account the climatic conditions and that are around it, right?
I would say that in terms of ecological succession, the kind of the biomes that grow on the area are of course limited of the climate and edaphic, so soils related conditions. So we cannot tell for any kind of the geographic what would be the ideal. In most cases, the forest ecosystem are more diverse one with the highest richness of the micro interactions. So there is one of the last succession stages on Earth, but there are some desert ecosystems that could be productive too. And even there are some farming application. Last year, I've seen in Peru that in the Sol Desert, there was 1,500 hectares of blueberries growing basically on the sand of the desert. Well equipped with the nutrients, well supplied with the water. So we could always think about of course, sustainability, because it's all about. And we need to figure out the role of microbes in shaping the soil as a living structure.
Okay, then to not make it clear that an ideal soil needs context, I'm wondering what then do all these solutions within agriculture need to focus on, right? Like what are the compositions of soil that solutions, or like in regenerative agriculture where you're focusing on, should focus on?
I would say it's a pretty complex idea, and I usually use an example of like trying to fix a Rubik cube. Then on every axis we have like plant genotype on the one, soil physical chemistry on the other, and the third axis would be microbial diversity. And we have all kind of combination with different soil types, with different temperatures, with different UV radiation, all kind of biotic and abiotic stresses, so all pathogens or drought exposures, and we need to fix by trying to adapt agriculture to common conditions to fix the correct proportion. And when it works, it is in line with the nature. So we could use a lot of the technology for bringing quality data. So the big data is important. So precise agriculture allow us to limit some of the resources, some of the inputs that we use, but we need to balance the soil biology to try to do it effectively. Because, for example, if we overuse some of the resources, some of the inputs like artificial nitrogen, we will end up with the plants growing like the addicts from external supply of nitrogen. So they would have no pressure to grow deep roots, to grow extensive root system, because they would be supplied with easy form of nitrogen. So in terms of the agriculture, we always need to have in mind that the whole soil biology comes through the long evolutionary process to adjust to local conditions. So sometimes we are just looking for the shortcut to bring our activities and try to like boost the activities. But I think that the precise agriculture needs to involve a lot of different variables.
Just so to understand better the picture, how does the, let's say, a standard, typical, conventional soil for farming looks now in comparison to how this healthy soil should be?
Sure. That's indeed a good question. So let's divide that soil picture into two subsequent or two diverse images. There's the one we have conventional conventional soil that is overtreated with the external supply of mineral elements, so soil applied elements. So we are providing the crops with the excessive amount of elements in fertilization programs. So usually the root system are not very deep because they in shallow areas behind the soil surface they could find what they need. Then we irrigate the crop in excessive manner. They do not have that adaptation to try to keep the water resources efficiently. But we could do it differently. For example, by limiting the nitrogen supply to the crops and focusing on providing the right conditions for the bacteria to grow. So building the organic matter in the soil, because the organic matter is the feed for the bacteria. We need to have it in the soil. In some arid environments, it could be limited. But if right balance, we have the bacteria, we have the fungi, we have nematodes, annelids, all kinds of micro and macrofauna in the soil that shapes the structure, so the structural integrity of the soil, shape physical chemistry, allow the soil act as a sponge, so generally keep the water for some later period, so in case of limited water supply, sustain the ecosystem. So in that regard, we have the bacteria that mobilize the elements, bacteria that are the food for soil animals, larger one that feed on bacteria, that again with their feces excrete the organic matter, and we are like a recirculating system. For example, in that intensive agriculture, we have a huge supply of nitrogen and the tank in the soil is broken, so we are losing a lot of the nitrogen. And in terms let biology works, we have different supplies. The one from the artificial resources is limited, but we have the dead biomass, we have the fungi, we have dead matter of the bacteria. So we have a lot of the small pipes that bring the nitrogen, allow the carbon circulation. It still would be leaking the tank on the soil. So we would losing some of the nutrients, but we have a lot of the recirculation system. So the root system of the crops grown under regenerative agriculture are richer, allow to get to some small packages of nitrogen in the soil and allow them to grow naturally even under the unfavorable conditions.
Let's dive into that actually, because and that would probably also depend on context, but
No, but we can put it in the context of farming, and then that is the like we can say like, yeah, in the context of farming and agriculture, and then we can just establish that as the context always.
yeah, but like it depends on where you're looking
Yeah,
at
true.
and what kind of ground phase. But I want to go deeper into like bacteria and fungi and their importance of like and also how they interact. But as I know, also if we can compare it to the human body, like it is a diverse microbiome, which for everyone is probably personal related, and that is also probably in interaction with your crop, depending on what you grow, etc., etc. But I know as well there are companies now establishing probiotic compositions, right, for soy, and probably it's all personalized in that sense. But for you, Michał, what are like microbiotas in general, fungi and bacteria that you would like to highlight because of their importance in the soil and which are mostly overlooked?
Yeah, I would say that soil microbes are more like team players. So you cannot really focus or oversimplify some specific. Of course, we could, by supplying external biostimulant, microbial biostimulant formula, we could try to enhance the composition forming processes. But in soil in general, in natural situation, we have a specific consortia. So a huge richness. You probably know that raw estimation that in 1 gram of soil, so 1 teaspoon, we have between 100 to 800 million of bacteria. We have few kilometers of fungi hyphae. We have 50 or more thousand of algae. We have nematodes, positive and negative. We have annelids, so earthworms, and all that groups of processes shape specific function. Specific bacteria fix nitrogen. Specific bacteria solubilize phosphorus, potassium, and other minerals in the soil. We have a specific bacteria that degrade organic pollutants. So we have that kind of functional consortia that work together in one network, and it is very specific to given locations, but very specific to different soil depths. It has been shown by the experimentation that we have the different biomes that are on the surface of the root, that are on the top layer, that are on the bottom layer of the soil. So the idea is the diversity is very rich, and science has shown that the diversity of soil microorganisms, when the crop grow, affects directly the diversity of human gut microbiome. So there is a direct link between those two aspects. So that brings us to one health theory, that generally we all as living beings have our own microbiomes that could differ when it comes to the species, that it comes to higher taxa of different microbes, but they're all connected and their functions are related to each other, because the grazing animals fed on the crop that grow in the soil, they are in the contact with soil. We as omnivores, as a human population, we also fed up with milk, with meat derived from the animals. So it all connects our metabolism and our diversity of our microbiome to a level that is connected between the soil microbiome, animal microbiome, plant microbiome, and our own gut microbiomes.
I'm wondering what microbes makes you excited, Michał?
I would say that still the soil is our black box. It's pretty matching to the soil, because we are finding still new things by the soil. And I usually use on my lectures an example that the soil science is not a rocket science. It's far more complicated, because it is very hard to try to limit the factors that we need to take. We even cannot recognize some of the factors that we need to take into consideration. And there are a lot of some new research. A few years ago, we have found the bacteria or archaea that produce hexadecanoic acid that leads to a release of serotonin. So generally, it is assumed that smell of the healthy soil that we could feel like going through to the forest is linked to the release of serotonin. So we're happy with not only enjoying the nature, but being close to the soil.
I think that we decided to do NASA, no, because it was too hard to understand the soil. So we said, let's try with rockets, no? I get that's how it went. In this part of the balance, I always wondered, also when I was studying, it's supposed to be bad microbes, good microbes. Is that something that is a differentiation that is done? Or is that then you need all of them, the bads and the good?
I would say that we need all of them, and they cannot be, in fact, the good or bad. I would say that there are balanced and unbalanced microbiomes. So we are always the same as with the stresses on crops. They are always face different kind of the stresses. We always would be exposed to some pathogens, but our microbiome, and by microbiome, I do not only limit it to our gut microbiome, but we have our skin microbiome. All parts of parts of our body have its own microbiome, and the role of that microbiome is protecting for the bad guys. But they have pretty good public relations. So a lot of the people recognize the microbes like the bad guys. And there is that popular saying that if you do not like we are not living in the right planet. So all about the life on Earth is about the microbes. So we wouldn't succeed. The plant wouldn't ever come to the Earth to vegetate on the soil if there would be no microbes. So I would say bad microbes are part of the ecosystem. It's like with the mosquitoes. We can hate them. They could be irritating. But if there are no mosquitoes, they wouldn't fit the birds, they wouldn't fit the bats. So we will have that imbalance in the ecosystem. So every piece of the ecosystem has their role to play, and the balance is the one to be good or bad.
I understand. It's just that sometimes, no, I guess, and overall, from a science communication aspect, a lot of times there are microbes there is the general word microbes that is bad, but if we go a little bit more specific, there are microbes that are associated with disease, for example, and there are microbes that are associated with, you were mentioning before, like this release of serotonin, but within the body, they help to digest. So there are certain strains that are better. I guess that talk of bad and good microbes always made me think like, well, is it possible to have, for example, a microbiota only with good microbes, or you need the bad ones as well? So that was always like, with that bad good differentiation, my idea was like, okay, so the bad ones are the ones that we do not have, or those are there as well.
Yeah, I would say that's our like limited perception to do so, because the bad ones are the tip of the iceberg, but they got all the press on them. So all the highlights are on the bad guys because that's what's the cause of the massive infections, whatever. But sometimes in the ecosystem, we need to have the bad guys to train the good one how to protect them. It's the same on when we take a human as the model, but the same as we take the crop as the model. Because crop also face some good or bad, or let's say pathogenic and beneficial microbes or macrofauna. So we need that all parts to take place. So first of all, is not no possibility to get rid of them because they evolved very fast. Bacteria and other microbials proliferate very fast, so the evolution is very fast. So we cannot stop it. The pathogenic exposure is also needed because it like trains our immunological system. It was also shown that, for example, the contact of soil affects our immunity and affects our mental health. So it's needed. If we have like artificial playground in the cities and we have like traditional one with the grass and soil behind, the kids are less prone to get any kind of immunity problems, allergies in the situation when they do not have the contact. And even some ancient civilization were using soil as a kind of the treat to not only get the nutrients, because some rich soils also contain a lot of the nutrients, not always in absorbable form, but they do so. But also the contact with our immunological system is very important to like the train with the bad guys, to train how to react to the different environmental stressors.
I only wanted to point out one more thing that I came up while you were talking is, there are microbes that are already extinct, like there are strains that it's because seem to be something like it can reproduce so fast, can grow so fast that, and of course that receives less attention than microfauna, no, that when we talk a lot about biodiversity and extinction, we tend to think of animals, no, tend to think of different animals. But is that something that we have caused or also as well, like extinction of microbes?
It is a good question and it's very hard to answer because our understanding of the diversity of the microbe is very limited. It is assumed that so far we do not even know 1% of the whole diversity of the microorganism. So it's very hard to predict if there are some extinct strains and what their role would be. Probably yes, because let's say the early evolutionary time when some first aquatic plants appeared on the lands, the conditions were totally different. There was a high UV light exposure. There was high content of heavy metals. The ozone layer was not yet formed. So the conditions were very harsh. So there were very specialized bacteria that allowed the soil formation process. So probably some of the ancient bacteria already disappeared like several millions of years ago in the evolutionary time. But I think that yet a lot to be studied. So that field of microbial biodiversity is still yet unexplored.
Yeah, like I can go on this topic because I know that there are also like startups and companies coming up with like probiotic as solutions, right, for crops and stuff. But actually, as you mentioned, I'm wondering if these are the solutions, as we have not well known, like you said, like 1% of all the microbes that we are understanding so far. How legit are these solutions then?
I would say I have studied deeply the topic because some of my daily activities are related to try to train the agronomists and make them understand the complexity of the soil. So generally, to benefit the soil life, we could take different approaches. We can work on providing a better habitat to the microbes. So, for example, by introducing regenerative practices, it is estimated that every year we could build around 0.5% to 3.5% of more organic matter in the soil. So we are feeding the microbes. But sometimes it's the situation like highly overused, highly cultivated, and the soil with deep tillage could be destructed so severely that sometimes the microbial biostimulants could do the job. So it has been shown that some consortia. So if we focus the same as the nature, not on the single strain approach, but we try to design consortium that is well evolved with specific crop, and we could add it to the soil, it could make the process of colonization of that soil easier. It is all anthropogenic effect. So if
Yeah.
a lot of the bad stuff on the soil, it is very hard to let the science to thrive again on that plant. So in many cases, the microbial biostimulants could be a remedy for that, to just gain some few years faster integration of the normal biology to the soil, because the amount of the microbes could be very limited after years of that overexploit.
Well, then, Michał, what are then promising regenerative practices that can help us building a better health? Well, it can help us building a healthier soil.
Yeah. That's the question that is just in point, and I would use a barometer of microbial activities, because if we are talking about the potential agronomic practices, we need to have this kind of the evaluation protocol. And in my personal opinion, and in the opinion of a lot of the specialists, what we could count on is the activity of the microbiomes. So there was a nice research a couple of years ago that was testing what type of regenerative agriculture activities could favor native soil microbiome. And it was integrated grazing, it was crop rotation and overcrops. It's all about sustaining that organic matter, but also limited tillage. We cannot go too deep with tilling the soil, because if we go too deep, we open it for the erosion. So we need to keep it covered. And the last part is also minimalize amount of inputs. So we need to rely on the soil biology. We could use the precise monitoring system to only add in the nutrition program the amounts of nutrients that are in scarcity. So generally that 4 categories are most crucial one for the regenerative agriculture that has been shown to contribute in the larger extent to enable high diversity and high abundance of different taxa that are functional in that soil health aspects.
And if you talk about the nutrients, what are they defined?
Nutrients, I would say we have generally, as we have the basic nutrients like carbon, hydrogen, and oxygen that build the biomatter. Then we have the macronutrients. So they are the building blocks that build this nitrogen, phosphorus, potassium. We need them, plants need them, and bacteria need them in the larger extent. And then we've got primary, secondary macronutrients like magnesium, calcium, and others. And then we have a wide range of mineral elements, including magnesium, zinc, copper, all needed in the right balance, all needed to control specific enzymatic processes. So generally, in the situation of stress, in the situation of suboptimal temperature, we need a proper nutrition. And we could do it by allowing bacteria to solubilize specific elements and provide to the plants as needed. There is generally a cry for help mechanism where the cry for help is the crying by plants. They try to find a microbial allies to allow to better react to changing and unfavorable conditions. So generally, in root exudate, plant release carbon, release specific secondary metabolites to try to trigger bacteria and make friends with them. And the bacteria help plants react and adapt to specific unfavorable conditions. So it shows us how complex the interaction network is, and that we need to take into consideration every player of that in that puzzle.
Since we were talking before about systemic perspective, and you're also now talking about all the players in the puzzle, do you believe that regenerative agriculture practices can be just introduced and have the impact that is expected without a major change in the food system? Or what are the things that need to change also along with it in order for regenerative agriculture to have the promised impact, let's put it like that?
Yeah, it is quite a complex topic because some of experts consider regenerative agriculture also as kind of oversimplifying, because we try to define a book of some recommended practices, and we could bring some carbon credits. Regenerative agriculture is still much related to sequestering the carbon with the program that subsidize the carbon allocation in the soil. And I think that turning to more regenerative systems is also educating the end users, is educating our society that in our daily choices, we need to focus on not only on the type of the ingredients we take to our diet, but focus on their origin. We need to know that some of the practices allow a better acquisition of the nutrients, so minerals, vitamins, but also specific phytocompounds, including phenolics, including all kinds of active like phytosterols or carotenoids that are needed to be in the quality yield. So we need to take into bear in mind during our groceries to choose the crop categories that could originate from different type of the cultivation. The same comes with the livestock maintenance. It has been shown that, for example, open grassland grazed livestock, cows and goats have different milk qualities. If we fed them only with the soybean-based feedstock, their immunity potential and the quality of the milk would be totally different. If we feed them in that open grassland, the qualities of the milk would be different. So if we want to have that regenerative practices implemented, we need to have well-educated customers that know that sometimes we need to pay a little bit more to have that more nutrient-dense food, because we need to favor the farmers to take that extra mile to produce a better quality food. Because in some case he needs to have a good equipment, he needs to limit some of the practices that could be done, or get rid of some of the plant control applications. So we need to favor this attitude, and we need to have this kind of approach in the society to try to reshape the full whole food chain system.
Keeping with this, I was just wondering, is it possible that there is mega farms that normally supply to retail companies and stuff like that, that they focus on like 3, 4, 5 crops or something like that, and they supply to a big extension? Is it possible that these mega farms apply or conquer on in these regenerative agriculture practices in order to restore the soil health, or those are two things that cannot go one with the other?
I would say that from my personal perspective and from my experience in the field, the big companies, and I do not want to mention the names, but the biggest one on the production chain with their subsidies in most of the countries over the world, start to focus on implementing some of the regenerative practices. And some of them, my activities are connected to educating, especially educating about soil health and crop requirements. And a lot of the companies were asking about delivering the trainings. But what was my assumption is that they made the promises, like on the political level, that they would try to turn into regenerative farming over some end date that were stated, but then they figure out that they have no idea how to bring it to the practice, because for some crops it is not so easy to turn not to regenerative farming only, because some specialty crops, some orchard crops, some traditional plant control for so long, it is not too easy to find the remedies for that. There are of course some crops that do not need to be so carefully managed. So there are some cereals that could live even in unnourished soil, not with the very good yield quantity, but at least they could thrive there. So the big guys, the big companies are focusing on that, but the risk is that the regenerative tag would be a new kind of greenwashing. So that would need to be carefully assessed if we are talking about the true regenerative, that we are focusing on the history of the ground, we are focusing on some metrics. So I am going back again about these microbial activity matrices that are needed to have this kind of the barometer. If we are bringing a diversity to the soil or losing it. So I think that it would need a lot of the public debate to focus on actual regenerating the soil, not only keeping to some of the tags that it's this new kind of greenwashing.
Yeah, I think it's important just because I wanted to mention that I would like to trigger in the audience that spark of a question that if they see like a big company in the agriculture sector all of a sudden starts doing regenerative, that maybe like a first sight of suspicion
Yep.
shall appear. Like if saying if a paper company tells you that they are working on and lowering the deforestation, no, it's like there is something here that doesn't sound
That
quite
doesn't sound
consistent, no. So maybe it would be fine that the people tend to associate like regenerative is not only like that. It's just as a nice tag. It comes with certain practices and consequences that is possible that a big company in determined context is not really applying.
very well summarized, and I think that is the huge risk where the public understanding and, let's say, some scientific cross checks are needed to keep it on the line, and of course keep our logic when we're selecting who is the stakeholder or the whole system, because the big corporate earn most of their money on the monocultures that they produce, not for the market itself, but for the whole feed chain. Most of the maize producer is used as the source material. Oils from oil crops are not mostly intended to our diet, but they are used for industrial approaches. So there is a big system, and we need to somehow balance the needs of the environment, needs of our quality diets, and to keep the system, the economy going.
Yeah. It's a very complex problem as well. I phrase it in a problem, and I think it is a problem. Another problem as well is like climate change, and I want to dive into that because as we talk about plants, plant health, and the future and new practices that can help us, basically bringing us close to a better future. I want to talk about like temperature regulations around plants because I have seen a lot of posts from you as well about how temperature regulation affect plant growth. I want to dive into that, and also like later on, like what are solutions that can help with
Yep.
this management. But what in your eyes are the most effective ways to manage plant stress related to temperature variations?
I would say it's one of the core topics I am involved in, and has been involved in studying the aspects from the wet lab to working on some theories and trying on that business part to work on some adaptation of specific products that could help us plant to adjust faster to the conditions. But generally, as per the crop, that that is exposed to some suboptimal temperatures, higher temperatures, higher evaporation. So plant generally adapts in two basic layers by adapting metabolically. So we need to balance the photosynthetic machinery to work effectively in that condition, but also it balance the transpiration. So plant has the stomata, so the tiny pores that could release the water vapor to cool down the crop surface, and that's the fine mechanism because they could cool down pretty fast. But then the trade-off is they produce less carbon, so they are less nourished. So in the reaction of the stresses, if we try to adapt to that climatic extremes, we need to first adapt the time of planting and harvesting. That's crucial. We need to nourish plants properly. By nourishing, I mean the fertilization program, use of inocula needed, use of agronomic practices and water supply, like submerging drip irrigation to allow plants to access the water resources that are needed, but also a selection of adjusted cultivars, because still scientists are developing new cultivars to merge some suboptimal conditions. So a lot of the new research is done to try to select the traits. Of course, most of the selection of the crops has been done on only the yield quantity, as scientists work on the diversity of root systems. It's not an easy job to tell you by heart. So the breeders do not do it often, because to dig up the plant in the massive scale to select new cultivars, it's really exhausting way to do so, especially on the commercial side. So generically focusing on some marginal traits that can be neglected in a usual way, but could be crucial when the stress appeals would be very important. So I would say the proper selection of the cultivars, maybe also a preparation of some like seed treatments or seed primings are needed for very hot climates. There are some approach that test if we prepare an environment that would be fine for a good germination of the crop, it could allow us to rely on the huge water quantities since the early emergence. So a lot of possible strategies starting from the plant, but also starting from the soil. Because if we prepare a good ground for well maintained the crop growth, that's also a good starting point to get the healthy crop.
I just wondering what you mentioned in the first and the second as well. I like timing is a strategy which we should count on, and I'm wondering because as we all know, like in with climate change, just on average we get just rising temperatures. That is the baseline. So I'm like looking for like how big of a role does timing now play in the future, right?
The timing changed. The agricultural practices timing has changed for the sector, because right now some of the areas in Europe that used to have the mild or rather a cold climate has increased the average yearly temperatures to a wider extent. And some of the areas start to be pretty good in wine production that usually favor some milder climates. So there is the approach to try to adapt the genetics of the plant to specific timing. So we could try at least use some climatic models that is done to try adapt what time of the year is most crucial. We also have some of the treatments possible, because we have the too high temperatures, but we also have the freezings that are like extremes that could happen in our central European area, the freezing in April or May, when the plants already start a generative development, so they start to the fruits. The frost in that time could ruin. So we also need to precisely monitor the health status of the crop and try to contradict. There are some possible organic sprays that we could do to prepare, for example, using a silicon as an element. It is like a shield that could physically protect the plants for some damage from pathogens, from over excessive evaporation, even for some freezing. So there are some available techniques that do not need to employ some harmful chemistry, but it's all about gaining the knowledge about the crop and getting some possible measures to try to contradict the extremes.
With the rise of climate, there is also the problem that certain crops become more vulnerable. Right now, we see it really patent with cocoa and with coffee. And what is the future that you see for these kind of crops? Right now, we are in this moment where also the plant-based culture is, or the plant culture is becoming to gain also some strength in that in that area. But do you believe that there is still hope for the plants themselves, or we have to go to the petri dish?
I would say that for some of the crops, some of the tropical crops, the value crops like cocoa and coffee, it started to be very problematic. And it started to be problematic not only about the weather extremes, that cannot be somehow contradicted on the larger extent, but also the price making factor for the crops was limiting the use of some traditional pesticides and fungicides that were pretty harmful, and there were some of the countries in the Latin America keep to use the chemicals, and the Europe blacklisted some of the chemicals. So the price rise of the produce is like from that two direction. The second one we could favor because that all about the product safety. But as I was speaking last year at the World Coffee Summit at Costa Rica, and I was trying to discuss that the possibilities to encounter, to introduce some regenerative agriculture practice, there is possibility even for such specific type of farms like coffee farming. We could use seasonal crops and perennial crops to grown in the same plots to employ easier water retention. We could use rational grazing just to get natural manure from the livestock and enable the nutrient flow. We could do a contour farming because mostly the cocoa grow on some changing altitude areas, so there is a huge loss of water. So we could do that contour farming or building the rorax, so the holes that could absorb the water. And also we could employ the climate resilient cultivars that are available, but it's all like long learning process, long application process, because it takes a while to grow a full fruiting tree. It's not so long, so short as for annual crops. So there is a lot of the investment also related to sensing the specific weather conditions on the farm. So, but there are some remedies. So we are not yet lost to go to that in vitro farming. So I think at least there are some, let's say, critical crops like banana when the genetic potential of the crop is very limited because it is usually propagated vegetatively, and most of the banana genotypes comes from very limited pool of genes. So it's very risky, as we are also in case of banana, we are cutting down the possible plant control fungicides, and we need to think about some sustainable remedies to keep the pathogen pressure lowered to enable plants to produce the fruits effectively.
So, like, well, you mentioned now banana. Like, this is a result of just overbreeding on the same crop, right?
In fact, in some of the crops, the effect of limited pool of genes that some high yielding, not only the case of banana, there are some others. So definitely one of the cases to adapting to climate change is keeping some new breeding programs because it takes a while for the cereal crops like wheat and barley that I used to work with. The selection process of new development process of new cultivar takes between 7 to 9 years. And for some of the vegetatively propagated crops like potato in our zone or banana as for tree species, it takes quite a long to develop and also employs a lot of the resources. So the science needs to meet the farming practice there and deliver the solution that would be needed.
But there is a faster way, right? It's called genetically modifying the
It is,
gene.
I would say, it is questionable in terms of public appearance. So there are the CRISPR system that could edit the genes, but we would say a lot of the GMO in the past failed due to the not understanding the needs of the market. There is a famous story of the first gene modified tomato cultivar that was called Flavor Saver. That was a kind of the variety with the extended shelf life. They knocked down the gene that was responsible for some of the processes of the senescence, and it basically could hold on the shelf for a longer. But no one cared because it was not tasty. They just selected the variety that was possible, but the tomato had no flavor, had no right aroma, so it was rejected by the market. So I would be very cautious when it comes to modification of the crops. There are some possibilities, for example, for co-breeding of crop and microbes to do the job in more natural way. So there is possibility to build natural consortia under specific environmental stressful conditions to make them cooperate with the plant crop properly. So I would say for the gene editing is a very shortcut, and we cannot tell. Still, the market acceptance is far from being full. So that would be cautious to go for the shortcut. But there are possibilities of that enhanced and figuring out all the constraints when producing the full quality crops.
And then what if AI comes into place? Like you use AI to go over the database of different genes and help them.
I would say it could be a game changer in understanding the complexities. So we just need, from the farmer perspective and from the scientist perspective, give the quality data. So generally, there is a technology that could turn the data to a true and valid insight, but we just need to get that right input. So proceed with our better understanding, collect a lot of the data from different geographies, from different soil types regarding the microbes, and also all kinds of mineral testings of the plants, mineral testing of the soil, and try to understand these variables and use the AI systems to try to turn that big pool of data into practical recommendation to solve that climatic constraints.
It sounds like the same futures for personalized nutrition, right? It's one centralized AI model that has access to all these quality data banks, basically, from different elements.
The thing with plants and with humans is the same, and maybe that is where AI can be a game changer, but it's really difficult. I mean, we already did the step of understanding what is the genome, and seeing all the parts and everything, but we still do not understand how do they interact. So that is like the thing that I was mentioning with the tomato. No, like we don't know how modifying like a simple gene has a whole effect in the whole. I mean, that is the place where we don't know like how AI is going to solve it, because if it helps us to understand much better those interactions, definitely is going to be much better optimizing where we shall do the changes. So yeah, in that sense is quite exciting, I have to say.
I think we are now also approaching the end, and we always have a closing end, which is coming back each time. But in that sense, we always give the guest the opportunity to ask a question to us. So, Michał, what kind of question do you have for us?
I would definitely like to ask you if you see that say soil-oriented topics a key for let's say the end users market. You think that in the future customers that are focused on getting that healthy food, that are interested about the diet, about the sustainability, would start to see that connection with the soil, because that would be the ending point that would be much more close to what the science tells us. So that would be nice to know your personal professional opinion on that.
I think it depends a lot whether customers get again knowledge of where food comes from. I believe that is a problem nowadays. There's like the typical thing. If you ask kids in New York where does the cucumber come from, they will tell you from the supermarket. No, like that. It's like they don't think of the whole process of how. And this is not only this is like the typical example, but this applies to kids and applies to adults, not because adults.
It does. A
Because
friend of mine did it even on broccoli. I came once.
Seriously?
Yeah, I had to cook at this place, and then I came with a real broccoli, and I looked at it. I was like, "What is this?" I said, "It's a broccoli," and I said, "Yeah, but I always buy it in the bag, right? Already cut." And I was like, "Oh, no. Yeah, I live in a bubble." It came to my mind again.
Exactly. That's the thing. If consumers become more aware of where their food comes from, then soil will play a factor, in my opinion.
And they will
Because
see the link with the soil.
Yeah, exactly. Because right now they don't know how a farm looks. They don't know how crops look. They don't. This is not a way of blaming. I think that the consumer. I believe that for some time now we've been getting farther and farther from our food systems and where the food comes from, and so in the future that I would like, consumers move on that way. They learn better, like where everything comes from. They go to the market, they ask to the farmer and which one is good, and the farmer explains why, and then they become also more conscious about the soil. The Tony Hunter used to say the world that we would like to, and the world that is going to be. I don't know how the world is going to be. I know that is an important factor in order for people to care more about the soil.
Can I add something to this? I don't think so.
Any observation or anything, whatever you want. Well, since Jaco has nothing to say else, sorry then.
Oh yeah, well, I have one question, but maybe I will do it.
But after the thing, okay.
Oh yeah.
Yeah, because this is the question, eh?
Yes. Is there something, Michał, that our audience needs to know about, like scientific breakthroughs that you didn't mention around plant sciences that you would like to mention?
As per general scientific breakthroughs that could be mentioned. So I would say the one aspect that I would try to cover a little bit earlier on. So that's that big data, how to collect so field mapping using drones and satellites to get the insight on the field. So I would say the breakthroughs start with collecting the data. Then we have that systems for monitoring nutrients in the crops and system of monitoring nutrients in the soil. So in the future of agriculture, the same as you mentioned in the future of like understanding the products by the public, it should be a knowledge-oriented decision. So we need to have a priori what is happening with the crop, what is happening in the soil, and only add the nutrients if it is needed. No excessive use of fertilizer. Then from the breakthroughs, we need to check on the wider extent the diversity of the microbiomes, because there is still not a common measurement protocol worldwide. That would be a breakthrough quite needed to have like a simple measurement protocol. There are some tools for that, and I would say more the data gathering for holistic crop management would be needed. So I wouldn't say that any kind of gene modification would succeed and would be that a turning point for the science. I would rather say that the congregation of all the data, whether they use or artificial or human intelligence, would be that critical part for the future. For just trying to connect all that points and bring up the insightful decision how to in a regenerative or sustainable manage control the crops. So I would say that the breakthroughs from a wide range of soil and plant sensing methods together with optimizing the soil conditions towards some breeding of new cultivars, but in connection to specific microbial consortia.
Well, then thanks a lot for the insights. But it comes the last question is...
I was already wondering.
No. I don't forget. Michał, what is your favorite food or dish?
My favorite foods. I usually prefer a Mediterranean diet, so a little of herbivore or of myself. I really, when I have some free time, except all that business activities, I really do to matching some nice salads with all the diversity of the plant inputs. I take them, so I would go for even as simple as a Greek salad if you do it passion. You give some organic olive oil, put a quality ingredient so you could succeed. I would say it's not about the kind, but it's about the same passion as mindfulness science puts to the food production. I would say that even a Greek salad could be a masterpiece to our food.
A very
Nice.
good Greek salad. I can agree on that.
I am a Mediterranean person, and as salads with good olive oil, good tomatoes, Greek salad, feta cheese, that is definitely.
But a good stack from regenerative grazing is also, if you tried a good meat, not with some, let's say, intensive grazing, there is also qualities of meat that you could even neutralize the carbon footprint. I would say that also by using the integrative grazing that you use the animal in the proper way, like circulating the carbon. So I wouldn't blame the meat. We need to see the big picture, because in the well-managed rational grazing that we could even integrate with the crop, they could be playing a substantial part. So I wouldn't say that the good quality stack with well-managed livestock is bad. So maybe not
like
together with the Greek salad.
First course and second course. Do you want to say dessert as well?
No, but I mean, when you want to, like, the only problem there is like it is like conventional farming. It's the overconsumption of meat that is more of a drastic point.
Yeah, because in that term we also need to divide the conventional that could really put a strong environmental footprint on that, but there are different ways. So we cannot tell it like black and white. There are still a lot of the understanding, but that's probably a topic for a different
could
talk.
be another.
Then we come to the next podcast.
I love it.
Well, thanks, Michał, a lot for sharing all your expertise. I think it's been a technical podcast, but still, I believe that really interesting, where we touched crucial topics in the current food system, such as not only the importance of the soil in our own health, that is something that probably is overlooked most of the times, but also the future and how can we tackle big challenges on our agricultural system that are very, very essential to understand and to take action about it. So thanks a lot for all your insights. We wish you the best on your...
Thank you for this invitation, for this great summary, and it was really a pleasure to exchange the insight with you.
Yes. Yeah, like as you know, I mean, you have a wealth of knowledge, so we could go deeper and deeper into certain topics, but I think that is for something for later as well.
In the second part.
I would love
the sequel will follow. Thank you so much.
Thanks
a lot, Michał.